Hey guys, welcome to this video. Our topic is transfer of thermal energy. We already discussed the methods to transfer thermal energy. We said the transfer of thermal energy uh, can be conduction, convection, and the radiation. We already discussed the convection. We've already discussed the convection and the conduction. So in this video, we'll talk about this radiation. Now, let's start with the concept of radiation. Radiation, this is the transfer of heat energy from one point to another without the requirement of any material medium. We've seen that there is a requirement of material medium in the transfer of in transfer of heat in solids and liquids. So basically, radiation is the transfer of heat in gas or in vacuum. Now, so this is the process by which energy in the form of electromagnetic waves is emitted by the heated surface in all directions and it travels directly to its point of absorption. Let's see examples of heat transfer by radiation. Now, before I just few of the examples of heat transfer by radiation, also known as the thermal radiation. First one is that the heating of the earth by the sun, whereby radiant energy from the sun reaches to the earth through the vast empty space that is the vacuum that exists between the atmosphere and the sun. The second example is the heating of a room by an open heat fireplace. The third one is the flames cause and the hot bricks radiate heat directly to the objects in the room, with a little of this heat being absorbed by the intervening air. So these three are just of vivid examples where heat is transferred in a vacuum, or also known as the thermal radiation. You have to note that the heat energy transferred by the radiation travels with the speed of light and has the similar properties of light. This means that the radiant energy can be reflected, absorbed, or transmitted to bodies. Now, the body which absorbs radiant energy becomes heated up and its temperature rises. So that's how radiant energy uh, it is travels, or that's how it is absorbed and transmitted. I see the detection of radiant energy. The radiant energy can be detected by the means of the thermopile. Thermopile, basically, this is an instrument which converts the radiant energy, that is thermal energy transferred in vacuum, also known as the thermal radiation, into electric energy. Now, let's see the factors for the thermal radiation. The amount of heat energy that is radiated by the body depends on the following factors. The first one is that the temperature of the body. Now, the amount of energy that is emitted depends on the temperature of the surface and its ability to emit energy. So, if the temperature is high, it will emit high temperature. If it's low, it will emit low. And its ability to emit energy it depends on its ability on how it can release the energy. The second one is the nature of the surface of the body. So here we're talking about how the surface of the body can be. It means that, for example, is it its nature is like it can absorb or it can transmit or it can reflect based on the such properties of radiant energy. The third one is that the surface area of the body, whereby the radiant heat is proportional to the surface area of the body. This means that the radiant heat, if the area of the object increases, so it means also the radiant energy will increase. But if the area is decreasing, it means also the radiant energy will decrease. Let's see the heat losses due to radiation. Now, heat losses by radiation can be made possible or controlled by the use of materials which can reflect the thermal radiations. Now, for a good example is how the thermal flask or vacuum flask in the hot pots can keep fluids and the foods hot for a longer time. Now, those are just diagrams. Those are just photos of the two. The thermal flask is a good example of material that uh, applies in this process due to radiation, and the hotspot also. They help to keep the fluids and the foods hotter for a longer time. Now let's see the working principle of the thermoflask. This is just a diagram of a thermoflask. It's a label diagram. As you can see, it has various parts: the metal case cover, the cork, double the bottom, the silver polish, uh, tiny metal cases, air, and the spring. Now let's see how this thermoflask works. Basically, the vacuum flask consists of the double the glass vessel with the vacuum between the walls. As you've seen in the diagram, the walls are silvered on the vacuum side, whereby the flask controls the convection, conduction, and the radiation of heat energy. Now, how it controls, let's start with the convection. The convection, it is prevented by the vacuum space between the walls and by the closing the flask at the top. So it means that there won't be heat losses by convection. Conduction, it is reduced by the container made of glass, which is a bad conductor of heat. We've seen that in conduction there could be good conductors and the bad conductors. So the conduction is reduced by the container made made of the glass, which is the poor or bad conductor of heat. Now the stopper is made up of the bad conductors, example the or rubber. So all these are just there as bad conductors for the reduction of heat losses by conduction. The vacuum is also a non-conducting space. The outer glass wall is the one that is supported by a pad of thread or cork attached to a plastic case. In terms of radiation is minimized by the silvered surfaces. The silvered surface reflects any radiant heat energy coming from the outside or inside the flank, flank or the vacuum for the flask. So that's all for this video. I hope it's clear, guys. We've discussed the heat transfer in gases known as the thermal radiation. I will see the various factors for the thermal radiation. And we've seen examples of thermal radiation in our daily lives. We have later on discussed the heat losses that can be in thermal radiation and the application of such in thermal flask. Thank you.